So hi guys, today we have another problem, that is find pair given difference, and the question states that you are given this array and you have to tell the absolute value of one pair, and that should be equal to this value, the x. If you consider 2 and 80, and it will make the absolute value that will be x, that is 78. So we can consider this pair, and we have to tell if there is such a pair exist or not. If there is a pair exist, then we will return 1, otherwise we will return -1. So this is our task for today. And another thing that is they mentioned that we cannot use extra space, and the time complexity can be n log n. So one thing is sure that we cannot use recursion here, because recursion will take 2 to the power n time to generate all the pairs, basically the take non-take approach. And for map approach, we cannot use map because map will take mm, n times, in number of space basically. So two approaches will be discarded from our list. So basically, let us think about something that will be helpful to us. So this is an unordered. Basically, there is no such pattern that will help us to determine the absolute value when we will reduce the absolute value or not. So to get a pattern from here, one way that we can sort this array, right? And we can get a sorted array, and the first element and the last element, the absolute values of uh, that two element will be the most. Suppose we were given 90, and the absolute value that we are generating from the first index and the last index, that is 70, then it is sure that no pair will generate that 90, right? But there is another issue. What is that issue? Basically, let us take this array. Okay, I have copied this array from here, and if we sort this, then it is 2, 3, 5, 5, 20, and 80. And what is the, okay, let us take another example, that is x is equal to 15. And how can I get 15? By using this 5 and 20, we can get 15 as an absolute value, right? So if we check from here and here, the absolute value will be greater than 15. Then you may think like, okay, so we need to reduce the absolute value, then we have to move here from here, or you can move here to here, but we don't know which to move, right? So we cannot use directly this by using this approach. So let us think for some different procedure, that is, you have already mentioned that the time that will take n log n. So it will be a hint for us. What can we? Basically, we can make something like that. Suppose the x is 78, that is given in our example, and we need to find some pair that makes the 78, right? If I consider 2 and 78 and sum up those values, that will be 80. Now we have to find if 80 is present here or not. And we know the this array is sorted already, so we can use binary search here. So that is the way we can find if there is a pair or not. So basically, we have to traverse this array and make this value. How can I make this value? Basically, the given x and sum of 2, and we have to find if this 80 is exist or not. And there is another thing, we cannot check for the current index. Why? Suppose this value is 0 now, and we have to find 78. Sorry, let us change it into 80. Uh, no, 80 will not be a better option. Suppose okay, so we need to make, that is 0. Okay, so if we sum up this value 0 and 0, so if I try to find the 0, it will also trigger, but that will not give the current answer, right? Our goal is to make the absolute value that will be equal to x, but already we have found that there is already a 0. So that will be not our current answer, because 0 and any other values that cannot make the pair that will be equal to x. Only this 5 and 5 will be making our answer. So we cannot use this technique. So we have to keep remind of this thing, that we cannot compare for the current index for that current index basically. Suppose we are searching from here, and let us think for the target value is 5, so we cannot check this on this element also, and we have to consider all the other elements. So this is a condition that we have to keep in mind. So yeah, this will be our answer or approach, you can say. And let us take another example, that will be x is equal to 15, our previous example. So how can I make 15? Basically, we have to traverse for the whole array and make sum of 2 and 15, that will be 17. So we cannot find any pair of them. So we have to move forward and for to check from here. And 3 plus 15, that will be 18. There will be no such 18 left. So we cannot say that we can have this pair. But when we can check for this 5 and 15, then we can get 20. Now we can say that there is a possibility to have the absolute value between 5 and 20, that will be equal to 5, sorry, x. So here, so when we have some pairs that will be satisfied with this condition, we have to return 1. Otherwise, when we can uh, iterate all the elements, so we didn't find any pair, so you have to return -1. So that will be our approach. So let us try to write the code. Basically, we have to initially sort the array. So sort, that is array that begin, array dot end, and this sort will take us in log n time, because maybe uh, the sorting that is applied here, that can be merge sort. So let us move for the next operation, that will be for int I is equal to 0, I less than n I plus plus. We have to traverse all the elements of the array and make binary search. So let us name it BS. So what will be our target? Obviously, we have to pass the current position and the limit, that will be 0 and n minus 1, and the target, that is x plus error of I. So let us complete our BS function. It will return int, or you can say will return boolean or bool. So BS, that will be int I, or you can say int current, int L, int R, int target. Sorry, fine. Okay. So let us make a while loop with the condition of uh, binary search. We all know that. We will continue, and int mate will be L plus R, sorry, phi 2, that will generate the mid position element. And if error of mid is equal to the target, then we have to return true. Otherwise, if the array of middle, that is greater than the target, then we have to check for the left side, that will L is equal to a mid minus 1, else R is equal to mid plus 1, and then return false. If we cannot find any such a pair, then we have to return false. And if this function return true, then we can say that okay, we have got the pair. We can return 1, otherwise we can return -1. So hopefully this is okay. Let us check it again. Okay, so middle is bigger than the target, and then we can shift, sorry, it will be r minus, and it will be l. Sorry, my mistake. Let us try to run. Okay, I have missed that condition that we cannot include the current element, that is I is equal to I not is equal to basically mid. If that is true, then we can return true. Okay, let us try to submit the code. Fine, it is working fine. So this is the approach to solve this question. This is a and modification of binary search, you can say. And what can the time complexity? Basically, we are traversing for the whole array, that will be n, and we are using binary search for each time. So the time complexity is n log n, and also the sorting, that will take also n log n. And yeah, so this is the approach, and we are not taking any extra space. So we are satisfying all the conditions that they have given to us. And okay, so this is the answer. Hopefully you have understood everything. Thank you. Bye.